such a design the database. In other words, after you design your data, the house, okay, this is the room, and this is the kitchen, this is the living room, this is the secondary room. Then we should know how to use this house after we build the house. Okay? So for example, there's an entrance door. So to get the entrance door, we need to think of that. Okay, then get into the hallway, the left-hand side. That is the living room, and in the living room you can relax and watch the TV. Or if you wanna take a rest, we can go to the secondary room, and so on. Okay, today we are going to discuss about the Socio operation, how to operate and design the database. For that design the database, we have used relational database model. So we are going to focus on the operation used for relational database model. That operation doesn't fit to other database model, like the object-oriented model, network model, hierarchical model. They have their own operation or their own manual. Okay, operation manual. So far from such information, we build conceptual design using the ER model. Using this one, we learn the steps 1, 2, steps 8, 1, 9. Okay, from ER model to relational model. So we have such a relational database schema. Okay. So eventually we will build the database using computer. Okay? How can we do that? We will discuss later about this one. This will include the SQL language. Okay? Before that, we do better know how to access such a design data, especially the relational database model. Okay? So to do that, we would like to introduce the relational, algebra, and calculus. By the way, what is an algebra and what is a calculus? What did you learn in your math? Kindergarten, you learned the math from the kindergarten, whether or not you learn, right? From kindergarten, you learned math. So basically, we can say such a math, like probably you learn the math for over 10 years, 12 years. Some of you guys are learning the math still, like the engineering math or statistical math. What is the two main approach, two branch of the math?
Logical expression.
Logical expression. One is algebra. Another one is geometry. Okay? So why don't you take a look at that, your kindergarten handout or the elementary. So something handout from your teacher in your elementary school. You probably see a bunch of shapes, right? So what is the name of this, how many sides? Then eventually you will learn what is the area of this, okay? How can, what is the height of the square, and what is the rectangle, and what is the distance of this A and B, something like that. This is geometry. So geometry is one of the important area of the mathematics. Why? Why don't you go back to several thousand years ago, like Egypt. So you know the Nile River. So anyway, to govern the country, okay, what is the most important source of the government money? It's still same. It's a tax. Okay, tax is the most important source of government money. But as you know, the Nile River is one of the river that civilized our modern society, right? So then, even though they have the very nice data, so many people can contribute on make the crop, like the agriculture, something like that. So the whole government can get a lot of money from by lending such an area or something like that. The problem is, from time to time, is blurred. They do not know which is which. Right? That's very important because the tax will be based on what? Area, size of the land. Right? So they need to they need to let the people know exactly which is my land, which is your land. This is how big is the area. So at that time, geometry was developed a lot. So calculate the distance between here to here. We know there is something important point like the tree or bar, and from here is the angle is 20 degrees, then the distance from here to here is 10, 20, something like that. Okay, what is the area of a circle? That is the geometry. On the other hand, algebra deal with what? Variable. Number. Then using variable and number, eventually what you need to do? Operation. So this is based on the shape. Okay? This is based on the operation. So you define such operation. Arithmetic operation, like this one, and bunch of other operation. And using that operation, you express something, the nature as the equation. Then sometimes you can solve the problem of the nature by using equation. Like I'd like to know the side length of this one. I know the length of this and angle. So how can we solve the problem? Like the x squared is the a squared plus b squared. Using this equation, we can solve the problem of this. This is an algebra, okay? Then on the other hand, geometry, we can do the same thing using only the shape. Like the Pythagorean theorem was invented by using such a geometry. It's the same thing in database, relational database. So to solve the problem of the database access, we are going to define several operations. Okay, some of the operations allow user to access the data. Okay, also you can manipulate the data. Also you can combine the data. Also you can find the unique data, something like that. Also you can limit the return the data. So we will learn such an operation. So that is the reason it's called the relational algebra. Eventually, just like what you did in algebra in math, so after you learn such an operation and number, instead of number, we define something relation, set. It's actually same concept. So what is a number actually? Number is a set, like a natural number, real number. What else? Something imaginary number and something number. All of these are actually defined as a set. Otherwise, you cannot even prove the plus, minus, what? Number is infinite. How can you prove infinite cases of the operation? A plus B is equal to B plus A. How can you prove? You need to check all the cases, infinite number? No, you cannot do that. Instead, you define the number, natural number is as what? Set. Just like that. We use such a set theory to define the relation customer and employee, something like that. By defining new operation to manipulate such a data, to access the data, instead of number, we have set. We have data, we have tuple. Then finally we can solve the problem. Problem is I'd like to, for example, you already defined such a problem in your case 1. So you list up the 10, 15 realistic queries in English. So list the customer who lives in Trumbull, for example. That's the problem. That's what you define in your case 1. Then we are going to represent such a problem, such a realistic query using operation and instead of number and relation. Okay? That's what we are going to do. Eventually, such an operation will be implemented in DBMS system as a language, just like the other program languages, C++, C++, Visual Studio, Visual Basic, and any other program language. It's a program language is a communication tool between user and computer. Okay, just like that. Because we are using the computer for database management system, we need such a language which is based on this relational algebra and database. Design the database based on relation. Okay, which is called structured query language. I know some of you guys learned already SQL without understanding this. That is the reason at the beginning of the class, even though you asked this several times, this is a table, this is a what, I asked you forget about such analysis. I didn't mean ignore you, but I'd like to give a chance to understand the fundamental of the relational database design. I understand sometimes without understanding this one, you can use the SQL like the select from where, but that is just the implementation part of database. Okay? Who knows? SQL will not be used next year if the Oracle Corporation is collapsed and bankrupt and like the project with big data, no SQL. I don't think relational database will be forever. For example, NoSQL is getting popular, which means there's no schema like this. Okay? However, if you understand such a fundamental of how to design the database, you can understand easily to catch up this kind of stuff. So today we are going to learn define such a relational operation. Eventually, we will learn relational instead of equation is called expression. Okay? Using the operation, you define equation. So using algebra operation, we will define relational expression. That will be converted to SQL later. One more thing. What about the calculus? When did you learn the calculus? First time. If you are a genius or advanced the math, probably the early high school, okay? Or some of you guys didn't learn the calculus. Calculus is based on algebra and there's the geometry is kind of the application, okay, in math, okay, that deal with more advanced part, like the differential calculus. Sometimes we try how to handle, for example, Zenon's paradox. Do you know the Zenon's paradox? What is the Zenon's paradox? In archery, so if I shot this one, can my arrow reach the other end of the work or target? Yes, definitely. So very quickly, my arrow will shoot on the target. However, Zenon asked you, did it reach half of this? Okay? Then next half, next half, next half, next half. Can this reach the end of the work or target? No, forever, half, half, half. It cannot reach. But it is not true, everybody knows. How can you break the Zenon's paradox? At the time, we can consider infinity. Okay? Number infinity, like a sequence infinity, something like that. So, or Sometimes we have arbitrary shape. Can we measure the area of such a shape using such a basic geometric concept? No, we cannot do that. However, using calculus, which is based on algebra and geometry, you can calculate the area of arbitrary shape sometimes. Also, you can consider velocity. You can consider something the more complex condition in math. That is the calculus. So calculus usually high level, okay? Operation, problem, tool to solve the problem. Calculus, the name of calculus comes from what? In Latin language, it means, calculus means it's a small rock. Why small rock is important, like the pebble? That small rocks were used for counting. Like long time ago, there's no number. How do you count your land? How many sheep, how many lambs, how many horses you have? Without number. So there's no way. So at the time, they used a rock. I have a jar, so I have, for example, 20 students, I have 20 rocks. One rock for each student. So this calculus starts from such a small rock, but anyway, so this calculus is a high level, okay? The operation, which is based on the relational algebra. In database, this calculus means using algebra operation and this expression, we will represent the problem using calculus eventually. So we will see the example. The more important thing is in database relational algebra. So we will start from the relational algebra. Okay? So relational algebra is an operation. So relational algebra expression is the number of sequence of such an operation, which means like an equation. We have operation, over 2 to the power square operation. So this equation is sequence of operations, just like that. So relational algebra expression is a sequence of relational algebraic operation. So we should know plus minus first. Then we can understand the equation next. Okay. So definitely we will use the company database that throughout the semester. First, what is the definition of the relation? What is the definition? What? What is a relation? In relational database, what is a relation? It's a relationship?
No, it's a table.
It's a table. Before that, table is another name of the relation, informal name, right? So how did we define a relation? Set of tuples. Set of data. That is the most important concept in relational database. We consider group of data as one set, one relation. Nobody did it before. Okay? That is the revolutionary data structure concept actually. So we will consider group of data as a relation, which means we should be able to access such a relation. This is the relation, table style relation, for example, ID, name, and address, and so on. So we have 1, 2, 3, and the name Lee, and Hunter, and James, and so on. This is a table, this is a relation. I want to access data by tuple, by row. Okay? So, first operation is it's a sigma, right? Better. Sigma. Sigma is called select. We try to select the data we'd like to select the tuple, we'd like to select the row by following definition of a relation. Okay? This is a select operation, the first operation to access the data. So we can access the data. One more important thing. Any operations in algebra, the relational algebra, any operation, input is what? What is the input of such operation? Select. Table or relation. Okay? This is a relation. It's a set. So any operation, input of any operation is a relation. Output. What is the output? It's a data, right? What is the set of data? It's a relation, right? So input and output of any relational operation is a relation. Okay? So which means, how can we use the select? Select employee, for example. Then output is something relation, which is not the same as the input, but something group of data. At that time, I want restrict, limit the return data as the DNO is equal to 1, for example. In other words, with condition. You can specify such a condition over here. For example, so DNO equal to 1 of employee. What does it mean? Select all employees whose department number is equal to 1. So you can put the condition as a subscript. Okay? And input is in parentheses. Output of this one is also relation whose DNO is equal to 1. Like here, this will be output. So it's another relation. This is a select operation. Then we can focus on the such a condition. Is it possible to use inequality? Yes, you can use any arithmetic operation. Or you can use logical operation. What is the logical operation? And or explicit or something like that. You can use such a basic operation in condition. Okay? So this is a select relation R with condition. It's used a lot. Frequently used. Okay? So this is called a sigma, but the name of this relational operation is select. Okay? This is the example of the employee. Select employee. DNO equal to 5. Then only this and this will be returned. If we want to add more condition like DNO equal to 5 and the salary is higher than 3,000 equal or 3,000. It will be this one, this one, this one, but not this one. So this one will be returned. This is a select operation. Output of this one is also relation. If you want to name it, you can name as A. So this is a new relation, A. At that time, you can, I do not explain yet, we will define later formally, but this is called rename operation. Rename of relation. Okay, I'd like to name the output of operation. Then we can easily used layer. So we can say this is the EMPDNO file, something like that. Doesn't matter. It's totally up to you how you name it. Totally up to you. Okay, so this is the select operation. Okay, good. The next one is, what is another definition of relation? A set of data, set of rows, set of tuple, and also set of attribute, set of column is another definition of relation, which means I want to access only ID and name. That's it. I do not need this column, this attribute. I want to limit. In this case, we limit by the data. However, in this case, I'd like to restrict the data by attribute. Can we do that? Yes, that is project. So this is called project operation. What is the input of project operation? Any relation. What is the output of project relation? It's the attribute, specific attribute, like the ID and name, which means it's a relation. Because it's a definition of, according to the definition of relation, group of attribute. It's a group of attributes. So input and output of project operation is relation. For example, employee. We can use a parenthesis to specify the input. And condition is the list of column, like for example, ID, comma, and name. Just like that. Simple. Output, another relation. You can name. So let's take a look at the example of the project operation.
So by means not select, right?
Which is,
By means not select. By.
where is the by?
I mean, what's the symbol of the signal?
This is a pi.
Yeah,
So
by means.
capital letter.
Okay, so it means select. It's
No,
not
this is the project. Projection. We write the project specific the column. Okay.
So we can select also, right? So what's the?
I do want to use the select together with this one. We will explain later. Okay. We are running plus minus. Definitely, we are going to combine the plus and minus in one equation. Okay, we will see. Such an example. First, project operation is set. So project, we can specify certain columns. Column or columns. Okay? So like this way. So we can use the subscript to specify the name list of columns of employee. Okay? So we can specify the attribute. Let's take the forget to explain about the select operation property. Definitely, it will allow commutative and associative rule that you know. Okay, you can change the order of condition, then condition 2, or condition 2, then condition 1, condition 1, and condition 2, or you can combine condition 1 and plus. Okay, so also it allows the conjunction of the all condition. So this is the DNO is department number 4. And salary is higher than 25,000, or department number 5 and salary is higher than 30K. Okay, then it will return like this. Then project. So we can use the project operation. Project allow the such a list you can combine. Doesn't matter. Okay, so example of this one. What will be returned? From employee, first name, last name, and middle name initial. This one will be returned, so this is the output of this, right? And what about this one? Sex and salary. This one will be returned. This is the output of this one. Am I correct? No. What's wrong? Which one? First one? Last name, first name, and oh, sorry. Good. So there is a salary over here, so we need to add. That's good. And another missing part. So how many tuples of this operation? How many? 1, 2, 3, 4, 5, 6, 7, 8. Okay? All 8 tuples will be returned with the first name, middle name, initial, last name, with the salary. What about this? Sex and salary. How many tuples? 1, 2, 3, 4, 5, 6, 7, 8. With the sex and salary attribute? No. It will return only 7 tuples. Why?
Because it began from 0.
Duplicate. Relation according to the definition of a relation. Can you remember that? Each relation should have uniqueness. In other words, primary key, right? That is the 3 major constraints. One is a key constraint. Second is entity constraint. Third one is referential integrity constraint. What does that mean? Each relation should have one primary key. Should be unique and not null. Then third one is foreign key constraint, reference. So why don't you take a look at this one? This should be a relation because the output of this operation. Man 30,000, man 40,000, female 25,000, female 43,000, man 38,000, okay, female 20. Okay, and then 25,000, then 55,000. So one of them should be removed. So this is very important. Relational operation does not allow duplicate data. Okay. What about the SQL? SQL. Have you ever used the SQL database query language? What about duplicate data? Does it return duplicate data or not? Yes, it does.
Yes.
It return even 1. No problem. Why?
Because they think that's a unique.
No condition. First time, the relational database management system does not allow duplicate data. But many users complain. Why the duplicate data is not returned? We need such a data. Then who will take care later? Okay? Also, it will take long time whether there exists duplicate data or not. Think about the 10 millions of data. How can you check duplication? You need to sort 10 millions of data. It takes a long time, which is not allowed in online transaction processing system, OLTP system. Okay? So very fast response time is critical. So later when they implement, the commercial vendor implement the relational database management system, they make the flexible query language, database language. However, according to the relational database model, they do not allow duplicate data. Okay? Keep in mind. We will see one more time in SQL how the SQL handle duplicate data. So output of this one is
If it's sigma, then it will return the duplicate data.
even though select any operation does not allow, any operation do not allow such a duplicate data because it's a relational operation. So output of this one is like this. How many tuples? 1, 2, 3, 4, 5, 6, 7. 27 because of duplication. Okay. So that is mentioned. Where is it? Here. Remove any duplicate tuples. Why? Because the relation, according to the definition of relation, it does not allow such a duplicate field. Okay. Rename. I need the name of the output because it's also relation. So you can rename of relation using arrow. So from here to here, R1, R2 is array of 2. So you can rename. Sometimes you can rename the output of the operation based on something meaning, like the department 5 and the right employees. You can easily understand. Usually, final output of the relation operation is a result. Also, I want to rename the column. Yes, you can do that. At the time, rename of the relation. The name of relation is arrow, and the name of column or attribute is using row operation. So row operation can be used like this. Row, and instead of ID, I need number. Instead of name, I need customer, for example. You can rename. Then output of this one is like the, from here. Instead of ID, it will be num and customer. Then data is the same, lead and to and contact. You can rename the column. What about the SQL data? SQL does allow such a rename or not? Yes, you can rename many times. We will learn later. That's the rename operation. So you should keep your mind, the order of column should be the same as this one. Okay? So what does that mean? How many operations? So two operations are combined. Does it possible? Is it possible?
Yes.
Even though I do not explain about such a combination, it's automatically possible based on what? Definition of that. Why? Any input and output of operation, they are relation, which means, for example here, this is R1, let's say. Something condition DNO equal to employee. Then R1 is also relation. So we can use R1 as the input of other operation. Right? Then apply we need ID and name. This is the result. So instead of this one, we can combine. Plug in R1 to here, ID, name, sigma DNO equal to 4, employee. Like this one. So you can make, this is called relational expression. Like equation in algebra. Equation is the combination of number and operation. Right? Plus, minus, divide, whatever. Same thing. Expression is the combination of relational operations. Because their input and output should be relation. So we can use any time, like this one. Okay? So far, input is how many relations for the input? 1. Always is 1. Even though relational expression, 1, employee, and sigma. Then this is the one relation. Then input of the projection. Then output. How many? Only 1. So that's the reason this selection, projection, renames are called as unary operation. Okay? It's a unary operation. But in mathematics, binary operations are more popular. Right? Plus. You need to plus 2 numbers. You need to minus 2 numbers. Something like that. So similarly, in relational operation, we have a bunch of binary operation, especially defined in set theory. So you can think about the set theory, set operation, like the union. What is? Union is
Two sets.
intersection. Yes. Minus this. Using Venn diagram. Same thing. Union operation, definitely we can use the set operation in relational model. Why? Relation itself is a set. What about the union operation? Which means when we have the two relations, it's a combination. All together. Okay? So that is the union operation. So we can use cup as a symbol. So what about the output of R in the union S? So it's a relation. Does it allow duplication or not? No. It does not allow. Okay? So duplicate data will be eliminated. One more thing. Just only for who knows the SQL. What about the SQL? SQL. What about the union operation? Do we have the union operation in SQL?
Yes.
Yes, we have. You can union to select. Does it allow duplication or not? No. Union does not allow the duplication. Why don't you test it? Instead, union or. You need to use the union or. Okay? Union or and unions are different. Union does not allow duplication. Union or allow duplicate A. In SQL, if you do not understand this one, forget about it. We will test it later. Only for those who knows the SQL. So, the union operation to return the social security number of all employees who either indicate you need to use union operation, works in department 5, or the directly supervise an employee who works in department 5. We can consider this example, this problem as two problems, small problem. One is SSN who works in department 5. We can make easily. Condition is DNO is equal to 5 of employee and social security number. We need a social security number, right? This is R1. Next, directly supervise an employee who works in department 5. Who's directly supervise an employee. Do we need an employee or do we need a supervisor? We need a supervisor, okay? Don't be confused. So we need a supervisor who's supervising, okay? are in the department number 5. That means that this require this can be solved easily using the later join operation. Okay? But we do not know what join is yet. So we can make several operations. Algebra operation first, then combine using the rename. So what do we need? We need employee information. Who works in department number 5 first? So employee I think that this is the same. We can use this one. Let's see the example. Use the example. Okay. So this is the employee who works for the department number 5, and also this is one department number 5 employee super SSM. We need to get the supervisor SSM from employee who works department number 5. Then we can union SSM. Union super SSM. In this union operation, there's one important thing. SSM is different from the super SSM. It's a different attribute. However, we can union. So when you union two relations, their type of the attribute should be comparable, which means it doesn't have to be the same attribute. However, their type should be comparable, which means social security number and supervisor SSN, they are the same domain. Okay? However, you cannot union social security number and first name. Okay? That's the same problem in SQL. So, always when you are using the set operation as a relational operation, their type should be comparable. That is called the type comparability. Okay? But it doesn't have to be the same name. Okay? So type comparability should be applied to the union, intersection, minus, and any set operation. Okay, so union example, student and instructor, union. So 7 tuples, 5 tuples, 12? No, you need to check the duplication. Is there any duplicate data? John, Ricardo, Susan.
Susan, yes.
Yes, Susan, yeah. And Francis, Ramesh, Sa. We have 2 of them, which means output is 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? That's the same in SQL also. And minus. We don't have to worry about the duplication in minus. Right? Because minus means this one. If this is not redundant, there's no redundant. The subset. Even intersection. Intersection part is a subset of the relation. So you don't have to worry about it. Only in union. Okay. Intersection. Difference. Minus. Definitely you know you cannot change the order. It's not commutative. It's the same thing in your elementary. And another set operation is a Cartesian product. What is a Cartesian product? I think we talked about it one time. Cartesian product. What is a Cartesian product? It's a all combination of elements, right? From two sets. It's the same thing. Cartesian product of the relational model means all combination of two relations. Okay? Which means we have the relation R, A, B column, C, D column, R1, R2, relational. So let's say A, B, C, D, 1, 2, 3, 4. R Cartesian product of R1, R2 means first, attribute should be A, B, C, D. It's a combine both attributes. Then the tuples is a all combination, which means